more I read mainstream media stories about 3i Atlas, the more I hear this particular comparison. My daddy always used to say that if it looks like a duck, and it quacks like a duck, and it walks like a duck, and it swims like a duck, then it must be a duck. Well, let's have a look at this duck. Not only does it look like a duck and quack like a duck, it actually dives for prey like a duck. Therefore, this thing must absolutely be a duck. My daddy said so. Well, you know what? My daddy said your daddy is a moron. Good afternoon, alien enthusiasts, and welcome to another Angry Alien Bulletin. So it's been a little while since I've talked about 3i Atlas, albeit not tremendously long, but nevertheless, in that short amount of time, so many new things have come to light, even though there are so many different sources in the mainstream scientific community and in the mainstream media that would like you to believe that this thing is behaving like a comet in almost every important respect, and yet it absolutely isn't. It really begins to make me wonder why these sorts of conclusions are becoming so popular, because it so clearly isn't true. Now, a comet certainly will start to get brighter as it gets closer to the sun, as more outgassing becomes apparent, as it warms up, the volatiles on the surface, and by volatiles we're talking about things that can suddenly go from a solid to a gaseous form, a process called sublimation, and this can include carbon monoxide, carbon dioxide, and water. So in that respect, yes, it's kind of behaving like a comet. There seems to be some kind of sublimation going on, or perhaps maybe that's what's going on. But it's also important to keep in mind that if this process is indeed taking place, it's not behaving in the same way that traditional sublimation takes place with comets. As a matter of fact, it's working opposite to the usual process. And not only that, there is evidence to suggest that this process was going on when the object, when 3i Atlas was 5 or 6 astronomical units away from Earth, an enormous distance, over 500 million miles. That being the case, it shouldn't have been sublimating anything. There shouldn't have been any activity at all to make it flare up, and yet it was active even at this immense distance. And that's just one of many things about this object that are very strange, that strongly suggest that even though it might look like a comet, as I suggested in the introduction, might not be a comet at all. Indeed, if this is an object trying to masquerade as a comet, it's not doing the best job. Sure, to the casual observer, just looking at it might look like a comet, sure. But when you look at it a little bit more closely, it becomes clear that this thing might not be a comet at all. I'm going to give you 7 different reasons as to why 3i Atlas might not be a comet. So first of all, does it look like a duck? Actually, no. According to a recent study entitled Extreme Negative Polarization of New Interstellar Comet, yeah, they don't give up on this 3i Atlas, the light coming from this object doesn't bear any resemblance to any comet that's ever been observed before. Light is a wave consisting of a coupled oscillating electric and magnetic field, which are orthogonal to one another in a plane that is perpendicular to the direction of the propagation of the wave, at least in a vacuum. In other words, there are strange oscillating electric and magnetic wavelengths that combine to produce the light that we see with any particular object in space. The polarization of this wave corresponds to different modes of field oscillations. For something called linear polarization, the electric and magnetic fields oscillate along a single direction, whereas for circular polarization, the fields rotate at a constant rate in their plane as the wave travels, either in the right hand or the left hand. Now, the level of polarization polarization displayed by an object which scatters sunlight like 3I Atlas reflects asymmetries in its global shape, and the polarization depends on the angle at which 3I Atlas is observed, namely the angle between the Sun and 3I Atlas and the 3I Atlas to observer axis. So in other words, the combination of these two axes should create some kind of polarization result, but the polarization that we're seeing from 3I Atlas is characterized by an extremely deep and narrow negative polarization, so negative in fact that it bears no resemblance to any other comet that has ever been observed. This polarimetric behavior is significantly different from all known comets, whether interstellar or those bound to the solar system, not fitting into either the low or high polarization comet categories. The combination of low inversion angle and extreme negative polarization is unprecedented among comets and asteroids, marking 3I Atlas as the first object known with such a behavior and representing a previously unobserved population. This polarization anomaly highlights the fact that 3I Atlas is different from any interstellar objects that we have observed in the past or any object observed within the solar system. Again, we're not sure what's causing all of this strange polarization of light, but if you also consider that the light wave generated by 3I Atlas seems to more closely resemble light that would originate from the object itself rather than reflected light, that is to say, 3I Atlas itself is glowing rather than reflecting the sun's light, that also suggests that this is an object that doesn't resemble a conventional comet or any comet at all. Now, associated with the appearance is the fact that 3I Atlas doesn't have a tail like any comet that we have ever seen. The sunward extension of the glow around 3I Atlas is opposite in direction to the tail of scattered sunlight that is commonly observed for comets. The physics behind these cometary tails is simple. Dust particles with a size comparable to the characteristic wavelength of sunlight, approximately 0.5 micrometers, scatter that light and hence are pushed by solar radiation pressure away from the sun. As a result, comets display tails of reflected sunlight that point away from the sun, but 3I Atlas exhibits an anti-tail that is far more significant than any anti-tail that's been observed with a comet before. As a matter of fact, only 8 comets with anti-tails have ever been observed prior to 3I Atlas out of 8,000 recorded comets, actually more than 8,000. What's even more remarkable is the fact that our point of observation on 3I Atlas is very unfavorable to notice an anti-tail in the first place. In most cases, anti-tails are an optical illusion created by the position of the observer compared to the direction of a cometary tail. Very seldom is an anti-tail actually material traveling away from the comet towards the sun. It's rather just the perspective of the observer that creates this illusion. But the line of sight connecting 3I Atlas to Earth was misaligned with the line connecting 3I Atlas to the sun by only 10 degrees, which means that we are seeing the extension of that glow nearly edge on, meaning that what we are seeing is not an optical illusion. The geometric correction factor for this projection is very, very small. What that means is if we were to board a spacecraft and hover vertically to the sunward direction above the elongated glow of scattered sunlight around 3I Atlas, we would actually see it extending 10 times further towards the sun than its width or tail. It has an anti-tail that is 10 times the width of the halo surrounding the object. Once again, this has never, ever occurred with any other recorded comet in history, not even close. Now, this anti-tail is a caveat into another observation that 3I Atlas really isn't behaving like a regular comet. The image that you're looking at right here was actually captured in early March, months before 3I Atlas was officially spotted. And apparently, 3I Atlas was active even at this point, almost 4 months before its original discovery, and when 3I Atlas was almost 900 million kilometers away from the sun. At this point, 3I Atlas should not have been producing any outgassing of any kind, and yet it was clearly an active object of some kind surrounded by a halo. Tough to call it a coma. Really, you can't call it a coma. Comas are comprised of icy, sublimated materials, and at that enormous distance, it was just far too cold for any sublimating to be taking place. Now, there might have been some dust at this early stage that transitioned into icy particles, something along those lines, but if that is indeed the case, 3I Atlas became active far earlier than any observed comet in history, once again behaving very differently from any other comet we've ever observed. But it gets even stranger than that when you start talking about composition. 3I Atlas isn't built like a comet at all. Traditional comets are comprised of icy nuclei that sublimate water as they get closer to the sun. There should be a lot of water in 3I Atlas's coma, and yet this spectroscopic analysis that was carried out by the Sphere X telescope showed no water whatsoever. Now, the James Webb Space Telescope did show a little bit of water, but we're talking about a tiny bit compared to the CO2 that is being sublimated by this object. 3I Atlas is spewing out an enormous amount of carbon dioxide out to distances of at least 348,000 kilometers away from the object, corresponding to a mass loss rate of about 70 kilograms per second, whereas the water emission rate at most is approximately 4.5 kilograms per second. That is significantly less than even tiny comets. This kind of ratio has never been seen with any comet in the history of astronomy. Again, how can 3I Atlas be a comet when it differs from all other comets this significantly? And not only that, there's very little carbon monoxide being emitted from this object as well. Now, if the H2O rate is low because it's still too far away from the sun, even though it really isn't, but assuming that is an explanation, then there should be loads of carbon monoxide coming from 3I Atlas, and yet there isn't. Again, this has never happened with any other comet in the history of astronomy. And connected to this anomaly is the fact that 3I Atlas isn't metal enough to be a comet. What do I mean about that? Well, the strange thing about this coma, aside from the CO2-H2O ratio, that's weird enough, but also the presence of unusual metals has made 3I Atlas unique in an extreme. So far, nickel has been observed in 3I Atlas's coma along with cyanide. As a matter of fact, the cyanide composition seems to be stepping up substantially as the object gets closer to the sun, making it change color. It started out as an orangish color, now it appears to be greenish. But all that being said, the presence of nickel without any iron is completely unprecedented in the history of all comets. Nickel-iron asteroids are a common thing in the universe, and also comets that are partially comprised of nickel-iron asteroid-like materials. That's a common thing in the universe, but an object comprised of pure nickel with no other materials being present, at least as far as metals are concerned, that has never happened. It has never been observed, and yet that is the case with 3I Atlas. And as I mentioned in a previous episode, the presence of nickel without any other metals is characteristic in the manufacture of many nickel-based alloys. For example, memory metals like nickel titanium. So now that we've started talking about artificial origins or artificial behaviors, we need to start talking about other things that characterize 3I Atlas that do not characterize interstellar comets. For one thing, it's too big. It's just too damn big. The extreme redness of the observed light coming from 3I Atlas implies that the light is coming from the nucleus itself and not from reflected material surrounding the nucleus. And if that is the case, and if the light has a wavelength of around 1 micrometer with an albedo of 4%, that implies a nucleus diameter of 46 kilometers. Absolutely huge. But if 99% of the brightness stems from icy fragments around 3I Atlas, which is perhaps true, then the nucleus diameter is about 10 times smaller, but still 5 kilometers or so. And even in this reduced size case, the mass carried by 3I Atlas is still 1,000 times bigger than that carried by the previous interstellar comet 2I Borisov, whose diameter was estimated to be about 0.5 kilometers. And also keep in mind, 2I Borisov emitted way more water into its coma than 3I Atlas has ever done up to this point. So a much smaller comet produces a lot more water, which is typical of comets, by the way, something that we would expect from a comet, even an interstellar comet, and yet that's not happening with 3I Atlas. But let's continue. The mass loss rate from 3I Atlas is a few times bigger than that coming from 2I Borisov, whereas its surface area is larger by a factor ranging from 100 times as big for a 5-kilometer diameter to 10,000 times as big for a 46-kilometer diameter. So the activity coming from 3I Atlas is very weak when calibrated by its large surface area. So as big as it is, it's not nearly active enough to be a comet, at least not a comet like 2I Borisov. But more importantly than that, an object this big simply should not be plunging through the inner solar system anyway. Based on all the asteroids and comets that we have observed in the solar system and the 2 interstellar objects that we've observed so far, smaller objects are far more common than large ones. So an object of this size should only plunge through the solar system once every 10 to 20,000 years. And we should have seen many smaller objects like a Oumuamua or 2I Borisov before we happen to cross something this enormous. It's very strange that we would encounter an object this big purely by chance, on top of all of its other strange characteristics. And then finally, we need to move to the final and most bizarre characteristic of all for this object. Unlike 2I Borisov and unlike Oumuamua, 3I Atlas is approaching the inner solar system at a trajectory that adheres very closely to the plane of the ecliptic. The odds of that happening purely by chance are about 500 to 1. But in addition to that, it is approaching the center of the solar system at a fantastic time, or a very convenient time, shall we say. It's approaching it at a time that will allow it to pass very closely to not 1, not 2, but 3 planets in the solar system: Venus, Mars, and Jupiter. As a matter of fact, it's passing much closer than 1 astronomical unit from all 3 of these planets. Close enough if it's an artificial construct, an artificial mothership of some kind, to dispatch probes to all 3 planets with ease. These probes could be powered by conventional chemical rockets, the likes of which are similar to intercontinental ballistic missiles, and easily intercept all 3 planets. The odds of all of these things happening purely by chance are tens of thousands to 1, perhaps as high as 1,000,000 to 1, depending on how frequently interstellar objects actually pass through the inner solar system. If they only pass through the inner solar system, say once every 2 or 3 years, the odds are closer to 1,000,000 to 1 that all of this could have happened purely by chance. And if you combine this with all of the other strange characteristics of 3I Atlas, the conclusion is quite clear. 3I Atlas is not a comet. It may be a natural object, but if it is, we need to rewrite the astronomy books for this thing because it is so different from any comet that's ever passed through the solar system or anything else that we have ever observed for that matter. Then perhaps it requires a category of its own because comet is just not a very good fit. Now, in spite of all of these strange characteristics, is it possible the 3I Atlas might still be a comet? Well, sure, yes. It might be just a very, very strange comet, a comet that's fundamentally different from any other comet that we've ever seen. But here's the question. Just how different does an object need to be? Just how unlike a comet does an object need to be before it's no longer a comet at all? Really, when it comes to most astronomers, if an object doesn't fit into a lot of other convenient categories, just calling it a comet seems to be the universal solution. For example, dark comets, these objects that aren't sublimating at all, aren't behaving like comets in any respect, except for the fact that they seem to be accelerating non-gravitationally, accelerating in a way that cannot be explained by solar radiation, pressure, or gravity flybys, or anything like that. And yet these objects are still accelerating on their own. Those are being called dark comets because they're accelerating non-gravitationally like a comet, but without any visible outgassing, which should be impossible, but they're behaving a little bit like a comet. Once again, it doesn't have to look like a duck, doesn't have to quack like a duck, it just has to kind of swim like a duck, and then it's a duck in the minds of these astronomers. And that's when all of these arguments start to get really ridiculous, especially when you consider that Avi Loeb has proven that at least a couple of these objects are actually human-made objects that we simply lost track of, interplanetary probes that malfunctioned, and we just didn't know where they ended up. But now they appear to have been misidentified as dark comets. So once again, are we going to start calling human-made artifacts comets? Well, obviously not. And for the same reason, if we see an object that isn't behaving like a natural object in any significant regard, then it's a very bad idea to categorize it, to pigeonhole it until we really know what it is. And it's unfortunate that the vast majority of the astronomical community doesn't seem to be adhering to that practice at all. Instead, they are 100% determined to call this thing a comet before we've really gathered enough information to categorize it at all. And that is a very irresponsible thing for a scientist to do. Thank you very much for watching. Please don't forget to like and subscribe. As you can tell, I am elsewhere. I'm actually in Australia right now, in the city of Canberra, the capital city of Australia, and looking forward to visiting my Australian viewers here very soon. Going to be scheduling some meetups very, very soon here, so make sure to keep your eye on all the different releases from this channel, including shorts. I usually announce a meetup on a short, so in any event, just make sure to watch for any new releases from this channel. Also, if you'd like to support these types of journeys, support the unusual content that I'm going to be gathering on this journey and others, well, the best way to do that is to support me on Patreon, and all the details are in the description. You can become a member for as little as $3 a month. Thanks again for watching, and until next time, stay angry about space.